reports of impossible Webb discoveries just keep coming. The James Webb Telescope has recently detected yet another mysterious structure that, according to our understanding of cosmology, simply should not exist. As is well known, it all began a good 2 years ago when Webb discovered 6 very early galaxies, the universe breakers, which appeared far too large and massive for their age, and thus turned everything we thought we knew about galactic evolution on its head. But now, the astronomical tide may finally have turned. A team of experts is certain it has uncovered the true origins of the problem galaxies. In reality, they are something completely different. So stay tuned until the end if you want to know what the scientists have discovered and whether our standard model is finally saved. Specially designed for infrared astronomy and up to 100 times more powerful than its scientific predecessor Hubble, the James Webb Telescope plunged into the depths of space on December 25, 2021, to revolutionize our knowledge of the universe. And indeed, it has done just that, albeit in a way that astronomers would probably have preferred to do without. One of Webb's main tasks is to detect the first luminous objects and galaxies that formed after the Big Bang and the subsequent Dark Age. And to understand why the discoveries made so far by the $10 billion observatory seem so problematic, not to say impossible, we need to consider the type of objects the experts had anticipated finding in this early chapter of cosmic history. In detail, there should only have been tiny baby galaxies in this era, for the very simple reason that, according to our standard model of cosmology, there simply wasn't enough normal matter at that time to form galactic heavyweights the size of the Milky Way. But apparently, the cosmos doesn't care much about our theoretical predictions. Defying all established models, Webb has found 6 early galaxies that existed just 500 to 700 million years after the Big Bang, and were already as developed as our Milky Way is today. In terms of numbers, this means that the so-called little red dots contained more than 10 billion, and in one case even more than 100 billion solar masses of stars. But how can this be? How is it possible that structures exist out there that are in such stark contrast to our standard model? Well, the first answer that came to Joel Leha's mind was, not at all. Which is why the study's co-author from Pennsylvania State University initially believed that he and his colleagues must have made a serious mistake. However, subsequent verification showed that this was simply not the case, making the problem of universe breakers an astronomical reality, a real problem for science. Against the backdrop of this discovery, co-author Erica Nelson from the University of Colorado in Boulder explained, even if only one of these galaxies is real, it pushes our understanding of cosmology to its limits. Leha's assessment struck a similar note. He said, "We found something here that is so unexpected that it poses a real problem for science." Given this, it's not particularly surprising that the earlier outlier galaxies have earned the infamous nickname, universe breakers. But why is this actually the case? How can 6 reddish spots of light have the potential to shake the very foundations of everything we thought we knew about early cosmic development? Well, that's easy to explain. In order to explain the existence of such massive galaxies at such an early stage, the matter density in the young cosmos would have had to be 2 to 5 times higher than our models suggest, or the structures would have grown in a way that is completely unknown to us. Soon after, however, it became clear that this was not an inexplicable isolated case, but apparently a galactic pattern. In fact, Webb went on to identify several other objects that, according to our understanding, should not exist. For example, there is the galaxy with the scientific name JADES, GS Z14-0, which graced the face of the universe just 290 million years after the Big Bang, and once again appears far too large and starry. The same can be said of the so-called red monsters that appeared in the data from Webb's near-infrared camera, NIRCam. These are 3 early dust-shrouded galaxies that have already converted 50% of their total matter into stars. That is 2 to 3 times more than usual, and thus once again contradicts established assumptions about galaxy growth in the early universe. We simply do not know what this extraordinary efficiency is all about. What we do know, however, is that the mystery of the universe breakers may now be at least partially solved. As mentioned at the beginning, a few weeks ago, a team of experts finally provided an explanation for these impossible galaxies and uncovered evidence that we are actually dealing with something completely different. What the universe breakers really are. Presented at the 245th meeting of the American Astronomical Society, the team led by Dale Kosenke from Colby College in Waterville, Maine, had set itself the task of evaluating the largest data set to date on little red dots, or LRDs for short. The bottom line was the equally astonishing and reassuring finding that the light emitted by the objects is probably not of stellar origin at all, but comes from completely different structures. After Kosenke and his colleagues reanalyzed the spectra of the LRDs, they realized that most of them show signs of very fast movements, of up to 1,000 kilometers per second. And such a pattern does not point to very early massive galaxies, but rather to the typical accretion disks of black holes. These are the characteristic disks of dust and gas that surround the gravitational monsters at their core and constantly feed them with new matter. Applied to the universe breakers, this means that around 70% of the LRDs found are not impossible galaxies, but rather growing black holes, also known as active galactic nuclei. And where most of the light is not attributable to stars, but to voracious mass monsters, there is consequently no need for an inexplicably high matter density to explain their existence. But what does this mean in concrete terms? Have we overcome the astronomical crisis and now have a complete understanding of the cosmos once again? Well, not quite yet. And that's not just because of the LRDs. But more on that in a moment. Basically, however, the new solution hypothesis still has a few problems. After all, the black holes in question apparently appeared in large numbers 600 million years after the Big Bang, before suddenly disappearing again 900 million years later. The reason for this development has not yet been conclusively clarified. However, one explanation is based on the assumption that as star formation spread, the amount of dust and gas in which the LRDs were previously immersed decreased, causing the emitted light to gradually shift from red to blue. However, Webb cannot detect this color, which means that the LRDs have not actually disappeared, but have simply become invisible to our technical eyes. So far, so good. And yet, we should not forget that the era of astronomical guesswork is far from over. Quite the contrary. In fact, it was only a few weeks ago that Webb once again detected a galaxy that is causing experts a major headache. In simple terms, it is a larger, precocious sister of our Milky Way. Although this galaxy already existed 11.1 billion years ago, it already had an impressive, fully developed bar in its center and was also 10 times more massive than our galactic home today. Elsewhere, Webb has confirmed a mystery that has been puzzling astronomers for some time. After a recent series of observations, it is now clear that the universe is actually expanding much faster than it should be on paper, according to the Standard Model, the so-called Hubble constant, and thus the expansion rate of the cosmos should be around 67 kilometers per second per megaparsec. However, astronomical measurements using supernovae, gravitational lenses, variable stars, and red giants provide a dramatically higher value of around 73 kilometers per second per megaparsec. And lo and behold, the most comprehensive data set from the James Webb Telescope to date has once again confirmed this discrepancy, with an overall result of 72.6 kilometers per second per megaparsec. Incidentally, astronomers recognized in the 1990s that cosmic expansion is fundamentally accelerating beyond this point. As a result, the mysterious dark energy was postulated, which counteracts the attractive force of gravity and is considered the engine of the cosmic acceleration. But now there is a serious problem with this theory as well. The largest 3D mapping of the cosmos to date has revealed that dark energy is not constant as previously assumed, but has instead become weaker. In light of this, experts believe that we may be on the verge of a significant discovery. After all, this mysterious force is a fundamental pillar of our cosmological worldview, which we may have misunderstood until now. In the most extreme case, this means that Einstein's theory of relativity is not correct in all respects, and that we will have no choice but to change our standard model. And if you never want to miss another video from us, you'll need to change your subscription status. Click on the thumbnail and subscribe now to stay up to date. We'll see you soon.